So, I mean, one of the things that people talk about a lot is this idea of deep learning. How much of that is the secret sauce, and what else are we going to need beyond deep learning?
Yeah. So a lot of the applications do come from that in vision and then in natural language as well. And we call it deep learning. And I sort of think if we go forward 5-10 years from now, we're probably still going to be using the phrase deep learning because it's a strong brand name. But I don't know if it'll be the same technology as what we have today, because deep learning can evolve. And I think really what deep learning, the important part.
I mean, they're already adding bits, convolution neural networks, adversarial neural networks.
It started out with basically one architecture, and now everybody invents a new one, but you still put it under the same brand name.
Like the brain.
Yeah, exactly. I think the key is to have models that are flexible enough, but not too constrained. You have to hit that sort of Goldilocks just right level. And I think started out, we had earlier models. There was a period of time when support vector machines were all the rage. But they were limited in what they could represent. And so you didn't think of saying, let's try to do machine translation end-to-end with a support vector machine, because you just couldn't imagine that it could represent all the subtleties that you need to represent. But deep learning, it seems like it's just about right. It captures those. But I think there's things we want to do more. So you've worked a lot in the field of planning. And I think we can't do that quite. We can't do all the things we've done in the past and replace them instantaneously with deep learning. So deep learning is good at pattern recognition, but stringing together a long series of plans, that's going to be a little bit harder.
So we're not going to do we're going to do perception with deep learning, but we're not going to do some of the deep reasoning.
I think that's right. And when you look at things like the AlphaGo, the Go playing program, and that was a hybrid. So it did perception. It had this idea that a Go board, you should basically use almost like computer vision techniques to get a gestalt of what does the board look like. And
am I winning, am I losing?
Yeah, so there's two things. One is, am I winning, am I losing? And the second is, what's an interesting place that I should consider playing? But that's as far as it went. The deep learning part didn't try to play the whole game. And after you did that, then you used the traditional tree search and Monte Carlo rollout and more sort of the old school approach. But it was a combination of the two that allowed us to play at world champion level.
And it ended up making some creative moves, or moves that surprised the Go masters.
Yeah, so even though it was trained to say, consider the moves that you've seen before that were the most probable moves, the search for good moves was broad enough that it could come up with some surprising moves. We had Gary Kasparov stop by Google last week. It was very exciting to see him.
On his book tour, no doubt.
Yeah, his book just came out. He joked that when he wrote a book about chess, everybody wanted to ask him about Putin, and when he writes a book about Putin, everybody wants to ask him about chess.
So what did you ask him about?
We asked him both. But one of the things he said was really interesting is he said human chess players are pretty close to perfection. And to beat them, you make one or two moves better, and now you've got it. He says, in his opinion, Go players make mistakes all the time. And so in that sense, it's harder to get that kind of perception and gestalt understanding of Go. But once you do, there's a lot more mistakes to exploit because it's such a harder game to play.